So we were talking about the system components, that is the cameras. So we just, because we are at this point at this moment. So we talked about the components. Now we're going to talk about the camera side. So this is just a bit of introduction we'll get into. As you advance, you have more content and more information on the same. So system components, you can see we have from the camera side, we have cameras for different installation modes. So you have cameras for different modes, including installation for corridors. You have installation for entrance side, corner cameras. That is a camera that can fit in corner scenarios. We have the panoramic cameras, which are inclusive of cameras that can have a view of 180 degrees. We have high altitude monitoring cameras, and we have the small cameras, that is the pinhole, commonly referred to as pinhole for the purposes of doing the undetected kind of surveillance. Then you have the thermal cameras. So for the system components, in transmission side, we have now the cables. That is, now from the camera side, we are sending information to the recorders. And in the transmission side, we have cables, different cables for different installation. For analog, we have the BNC cable and BNC connectors. So it's a coaxial cable and a BNC connectors. For the IP side, we have the RJ45 and the Ethernet cables. Then we have the fiber. We have the interface. This one is connector for this, the RJ45 for this. Then for fiber is this one. So we also do support wireless transmission, and we have wireless products. So wireless transmission is regard with the installation scenario where you're feeling that cables might not be of efficiency. So you need to do wireless transmission, and we have different kinds of wireless transmission, including devices that can be installed in elevators so that you can achieve wireless transmission for the same. So for the system components, now the storage side. So the storage side at this point has been generalized. So however, the recorder and network storage are a bit different, but they achieve the same purpose of saving the information from the camera to the storage side. So displays, we have different kinds of displays. So these are just some of the brief introduction of the products. For the display, we have the LCD, we have the LED, and also we have the DLP display. So a question, what about cloud storage? So cloud storage is so cloud storage at the moment as a company is the cloud storage has not reached us, but in case you need something information about cloud storage, or you need to have backup with our cloud storage, you can contact us so that we can do a follow-up on the same. But it's a service that we have these products that can achieve cloud storage we provide for users. So these are just basically, they're called EVS, and the EVS has slots. So this one has slots for hard disk. So you can add hard disk here, support even up to 16 terabyte, and others can go even up to 84 hard disk or 48 hard disk, depending on your requirement. So for the display, we have different kinds of display for video walls and normal TFT display, and an LED display that is for the outdoor side, and DLP kind of display. Now, so maybe for those of us maybe who might not be following, you're just talking about the components of the CCTV system. So we talked about the camera, we talked about the recorder, we've talked about the display, and now at the control center. Yes, Zion ICT. So you can unmute yourself and you can talk, because it's a session that we can interact, all of us. So you can either type a question in the chat section, or maybe you can engage directly with me. So we talk about the control. So control comes in terms of maybe sending the information to the display side, or maybe controlling the components, including cameras. So you might have PTZ or the 360 degrees cameras, and you want to think. Sorry for the network interruption. Can resume. So I was talking about the control product. So the control products interact with the recorder side and the display side, and we have different kind of control products, including keyboards, that is for the control of PTZ. We have decoders where for the point where you want to achieve video wall functionalities. So maybe you have about 9 screens and you want to do video wall with the same, you can do decoders. And then we have the high-end type of decoder, which can do more than it can even do up to 20 screens for the manipulation of information to the display side. So maybe for the video management system, the platform. So we have different platforms used with our products. We have the IMO. IMO is another brand that the company does, and it's just a small brand, more like to do with the home-based products. We have the DSS and the industrial platform side. So we'll get to talk about these softwares maybe later. So I think from there, we can now go to another topic. So you can do now basic knowledge of camera, now dive a bit into more topic of regarding the basic knowledge of camera. So you're going to talk about the basic knowledge of cameras. We get to know about information of a camera, the important parameters of a camera. Maybe talk a bit about the functionalities that we have for the camera side. So you're just going to cover this at first. So we're going to begin with this section of the camera side. So the camera being the front end, we talk about it. So the cameras that we have as a company are categorized based on different features. So our cameras can be categorized based on the type of sensor the camera has. Apart from that, we categorize the cameras based on which kind of signal the camera outputs. So depending, we can have analog or digital cameras. We can also have the network side, that is the IP cameras, and we can also have the digital cameras as a whole. So we also do categorize cameras based on the definition the camera has. So you can have different size megapixels cameras. We also do based on the operation mode of the camera. We also have the image mode, that is in terms of how can the camera performs in a situation where you have high light or low light, etc. And also in terms of appearance. So maybe in terms of we talk about cameras categories. What is the difference between network and digital? So they are more of the same. So there's no much big difference because it's more of the same. Because we have only two types of signals, that is the analog and digital. So I think maybe in terms of network here, they were talking about functions like achieving features like 3G, 4G. So that is the signal, and it's doing wireless. So in terms of network, I think it's more of wireless side, not necessarily wired digital. So we have based on the signal of the camera, we have the traditional analog cameras, and we have HD analog cameras, and we have the network cameras. So the traditional analog cameras are the very old model cameras which did not do very high resolution. They were very low resolution. Now we have the HD analog cameras, that is the new modern analog cameras that can do even support of 4K. So you're doing a support of resolution of 4K in a display for the new HD cameras. Then we have the network cameras, which now can do even better performance in terms compared to the analog cameras. In terms of camera appearance, we have different camera appearances. So in terms of appearance, we have the box cameras, we have bullet cameras, we have IR bullet, we have vandal-proof dome. So vandal-proof means the kind of camera that it's hard to tamper with, or maybe it's hard for someone to steal. We have the eyeball. So we have the dome and eyeball dome camera. So you can see the difference between the eyeball and the dome camera is there's something like a ball for the eyeball. So it's an eyeball dome. Then we have the speed dome cameras. We have the panoramic cameras for the view of 180 degrees. We have the small cameras or the pinhole cameras. We have now the mobile cameras. So mobile cameras in terms of installation for lifts in vehicles, etc. Those are mobile cameras, and IoT cameras and NPR cameras. So a normal camera, a typical installation for bullet cameras is in corridors. So in a scene where you want to have a large or a longer view, you can use the bullet cameras. And for entrance side, you can use and indoor situations with a slightly shorter view, you can use the dome cameras. For the corner side, we have cameras for the corner cameras. We also have the panoramic series cameras. So the panoramic cameras can view wide angle, including a view of 180 degrees. So that is the panoramic cameras and 360 degrees. So mostly 180 and 360. So in execution of this camera, so this is a kind of panoramic camera which has a PTZ at the bottom. So you can see you can have a lens here, another lens here, another lens here. So you have multiple views, and at the end of the day, you have a full view of the region that you are surveying. You also have the PTZ camera. So PTZ is in terms of the tilting, pan tilt and zoom. So the pan tilt and zoom is with regard to the position which the camera can move or achieve. So we also have the thermal cameras. So different thermal products for different applications, including homes, security, border patrol, and other functions. So you can see a thermal camera, what a normal camera cannot see, a thermal camera can be able to see. So you can see a thermal camera can see a person, while a normal camera cannot see the person. Okay, we just talk about the brief working principle of a camera. So the general principle working of a camera. So for the exam purposes, you need to understand such information because the information can be covered in the exam. So the general working principle of a camera is that so this one is a camera, this is the camera, this one is the camera. And the lens will focus the images to the sensor. And then the sensor will there'll be the conversion of that captured image in the sensor to digital signal for processing. Then it will be processed in these processors, the ISP and DSP processors. Now, for analog camera, because it's using the analog signal, there'll still be conversion of the digital signal now back to analog, so that it can be transmitted using the coaxial cables you can see here. So this is an analog signal being transmitted here. Well, for a digital camera or a network camera, so the same working principle. However, in terms of the signal being output is a bit different, which is you're going to have an digital signal output here, not an analog signal, 1 zeros and 1s. Can I get someone is asking, can I get your materials for my further studies? Yes. You'll register into the e-learning platform. I'll show you when you complete the training. But today I'll show you how to register and access the materials. Yesterday we covered that. So that's the basic working principle of a camera. And we now talk about the parts, the various parts of the camera, so that we understand the basic working principle of the camera. So for the parts, we have the lens, the sensors, and processors. So the camera is composed of 3 parts: the lens, the sensor, and the processor. And so the lens is used to focus the light into the sensor. So you just understand that functionality. And you have different kinds of lens that we provide as a company, or like the cameras employ. So we have lenses that are fixed, that is the distance between the lens and the sensor is fixed, while others, we have the varifocal lens, which are type of cameras where you can adjust the distance so that you can get images based on your zooming in and zooming out. So you can see this distance here, the focal length I'm talking about. So the focal length, we have different products, different focal length that we employ for our cameras. So we have focal length of 2.8 and 3.6 and even 12 millimeters. And you can see the smaller the focal length, the larger the angle of view, or the field of view. And the larger the focal length, the smaller the angle of view. So you can see the same here. So also it's something that you need to understand while choosing for cameras and for various installation scenes. So maybe some properties of the lenses. So I've talked about the lens, which is used to focus light. And we have different types of lenses. We have the ones that you can do manual focus, and you have the motorized focus, or the motorized lens. That is the lens that you can adjust the focal length using remotely. Well, the manual focus, you need to adjust it manually with your hand. So another part of a camera we talk about is the iris. So the iris is the opening to the lens, to the sensor, sorry, and it controls which the amount of light that can go to the sensor. So if you can see, if you open the iris too much, you can allow more light into the device. So for this kind of cameras, that is the, let me just show you. So we have this kind of cameras. So we have the box cameras, where you have the body is separate from the lens. You just mount the lens here directly. So you can see this lens here is being mounted at this point here. So we just talk about the various ways that we can mount this lens to this body of the camera. Just talk how we can achieve that in the properties of a camera. So for lens mounting, we have different kind of mounts. We have the C mount and we have the CS mount. So for a C mount lens, it needs a C mount body, and a C mount lens can still work with a CS mount body. A CS mount body can go with a CS mount lens, but you can't do a CS mount with a C mount body. So these are just some of the methods that we use to mount lenses to bodies of cameras. That is the box cameras. Another important part of the camera is the sensor. So the lens focuses the light to the sensor, and sensor now is used to create the signal output that is similar to that image. So the sensor is a photosensitive element, which based on the images that is being focused on, it creates a voltage or a corresponding voltage from that image. And because the sensor is a very small, and the voltage output is very little, there needs to be done an amplification of that voltage so that you can get a usable volts, that is a higher volts, now for processing purposes. Now what is done after amplification of that voltage, we have now the conversion of that analog signal, because the light is an analog signal. Then it's converted to digital signal, which can which now is for image data, can be used for image data processing. So now we have now different kinds of sensors. So the sensors that we employ as a company include CCD and CMOS, although we have other kind of sensors. But for the certification purposes and maybe for the cost purpose, we have these are the mentioned one. And you need to understand the difference between the two. So later in the naming rule of our products, we'll talk about how we identify which kind of sensor the camera employs. So for those of us maybe who are not following me at this point, so we've talked about the lens, we've talked about the sensor. We are now at the processors now here. So we have two kinds of processors in a camera. So we have the digital signal processor and image signal processor. A DSP is basically like a CPU. So it's like a CPU in a computer. It's like the central processing unit, and it's used for processing the image data, and can do realize algorithm application, improve the image effect, etc. While image signal processor is a kind of processor that is focused more on images. So take it like this: if you have a computer, we have the graphics card, or the CPU. So the CPU will be the digital signal processor, while graphics card will focus like more of images. It's the ISP. And we have different kind of manufacturers for the image signal processors, including NVIDIA, Silicon, and Umbrella. So you can check for yourself maybe for that later. Maybe you can be asked what the difference between a DSP and an ISP. So we talk now in terms of camera performance, how the various now features for the cameras in terms of the performance. So we'll handle about resolution, what is BLC, HLC, WDR, white balance. So all this function, we talk about it in a short while. So the resolution of a camera is basically the number of pixels that is contained in an image. And the higher the resolution, the clearer the image, of course, corresponding to the size of the screen. So we support even up to 32 megapixels. We have 32 megapixels cameras. So the lowest kind of resolution that we have is the CIF. So you can see resolution. So different kinds of resolution, a 4K camera and a 1080 camera. So you can see more pixels in this 4K, and the image becomes even clearer. So horizontal resolution, maybe if not clear, I think this one you can check. Can just do a reference on the same. What is the horizontal resolution? Let me just talk about this HLC, BLC, and WDR because you might encounter it and maybe interact with it while look for configuration. So with an example, you can see the image on the left and an image on the right. So you have two kinds of images. The first image is that the picture was taken, but at the forefront, we can't see the people clearly. So you can see with their faces very clearly here, but at the back, we can see it very, very good. The other image is at the front side is very bright and the back side is very dark. So you can't see what's happening at the back side. So how do we fix this one? So a backlight compensation, BLC is a technology that is used to enhance brightness so that we can see objects that are in dark scenes to be a bit bright. So if you see BLC off, BLC on, you can see now the people at the front side can be seen clearly. However, the problem is that we have altered the images at the back and it's even more brighter than we expected. So the image at the back cannot be seen. HLC on the other side will try to reduce the highlight, the brightness of the scene so that you can have a optimal brightness. The disadvantage is that maybe the information at the front will be lost a bit. And now we have the WDR, which employs both HLC and BLC. So WDR will employ the HLC and BLC so that you can have clearer images both at the back and at the side, at the front side. So that's the simplest way I can explain the HLC and WDR. So also talk about the white balance. So white balance function of a camera will try to balance the color temperature of the scene so that it can make the images look a bit white. So color, black and white. So the technology that is used to switch between day and black and white images and color images is called the ICR, which is this. This is the ICR sensors, which can sense whether it's a day or night so that the camera can switch accordingly and light these lights here so that it can create a black and white images. That is the infrared rays. So the ICR sensor, so I've talked about the ICR. So We talk about the ICR technology, infrared cut filter technology. Dual filter, which is used to remove images that appear like pinkish on the screen. So you might have installed a camera and then you are experiencing that the images is quite dark. So how can you improve the brightness of the image? So you can use a lens with large aperture. So large aperture means allowing more light into the sensor. You can use a big sensor so that big sensor can read more information into the scene. You can use the AGC technology, which can be used to amplify the electric signal so that you can improve the brightness of the scene. So we can use the minimum. We can use lux is used to judge the performance of the light quantity in a particular scene. So you can see if a shutter speed is set to lower, fast images can be captured easily. So I think we'll do a session about troubleshooting images or maybe scenes with CCTV later. But for your case, just understand these technologies, the electronic shutter. So when the image is too fast, you can reduce the speed, the shutter speed. If the scene is also very dark, you can try to reduce the shutter speed. The AGC technology. So AGC technology is used to increase the brightness of a scene, but the problem is that you are increasing the brightness of a scene, but at the same time that you are amplifying noise. So you can see from this image here, the noise comes in such a way that there's these small white spots, very little white spots on the screen. So you can see the image, but at the same time you're having some white, very small white spots. So, and how do we reduce this white spot? That is the noise. So we have different methods of noise reduction. And one of the methods of noise reduction is called the 3D noise reduction, and we have 2D noise reduction. So 2D noise reduction works by analyzing individual frames of video and correcting those pixels that likely present noise, while 3D noise reduction analyzes between different frames in order to adjust pixels and improve fidelity. So 3D NR is a bit better than 2D NR. Starlight technology, which I just talked a bit about Starlight technology. So Starlight technology can also be is a technology in the camera, and we'll get to know in the naming of products of cameras. How do you know a Starlight technology camera is? So Starlight technology camera will improve the brightness of a scene, or use the low light to advantage and create better images. So you can see a Starlight camera picture while an iPhone 6s picture at the same side. So it works very well with the minimum light. We also have the IR cameras. So IR cameras means those infrared lights cameras, and the IR are inclusive of these small bulbs here, which are used to create black and white images at night or in low scenes region. So a smart IR, so just like an IR technology, smart IR will switch accordingly and not only create black and white images, but create black and white images which are clear to interpret and easier to understand. So in terms of exposure, so it will not like create bright images, but try to balance color black and white in the scene. So PFA technology. So we talk about some of the features of the camera. PFA technology is a technology that can achieve focusing while zooming. So like a camera that with the PFA technology will focus the image while you're zooming it. So focusing and zooming it at the same time. While one without PFA, you'll have to zoom first, then do focusing now. So quite in handy while doing a PTZ scenario. So you can see without a PFA is not focused, while the PFA one is focused. So this Dory distance. So most of the cameras, if you go to our website, you check the data sheet or specification, you'll see Dory distance. And Dory distance is useful to determine which camera that you're going to install and actually check what particular point. Let's say you want to do face detection, so you need to confirm with the Dory distance. So it means basically detect, observe, recognize, and identify. So the camera maybe can identify people easily, very good at 8.1 meters. Others can do very well identification at maybe even more meters. So you can choose those products based on Dory information. So the protection rate comes in terms of rating of the camera. So you can check these values and you need to understand them, which value represent which purpose, like IP67, 68, 69 can do water jets. We can check on that. So we talk about the intelligent functions of cameras. So we have the IVS. So we have different IVS rules that we provide as a company. But for the basic purposes of this examination, we just talk about the tripwire intrusion, missing or abandoned object. So tripwire means drawing a virtual fence or a virtual line in a scene so that someone crosses that line, you can create alarms based on the same. An intrusion is a type of an IVS rule where you are creating a logical area like a box or a different kind of square, so that in case someone enters that box or leaves that box, you can have alarm on the same. We also have the missing or abandoned object. So missing means if an object is removed from that scene, you can have alarm on the same. Or if an object is left at that scene, you can have alarm on the same. So you have also the face recognition. So face recognition is to identify a digital image, a person from a digital image. So video structuralization. So give me a break. We just take a small break. We come at 10 minutes past 3. So 10 minutes. Okay, we come back at 6 minutes past 3 so that we continue. In 6 minutes, we resume. So let me just end this. Then you rejoin again with the same link in 6 minutes.